Hi and welcome to Maths class. Today we're looking again at expanding two sets of brackets. But one of the things that's going to be different today is we're going to be looking for patterns, because when we expand using FOIL, what happens is I have to do these firsts times these outsides and these insides and these lasts. But quite often there are patterns we can see where we can skip that step and just write the answer down straight away. So the first exercise is what I want you to do is look for patterns in the examples you've got here. So I want you to pause the video and then I'm going to go through and just write down my answers, and I want you to check your answers. But as you go, what I want you to do is start thinking, I think I see a pattern here, and then maybe predict what your next answer will be. And if you got the answer right, then you know you're onto something. So each time, once you think you're onto a pattern, predict what your answer will be. Then hit play and you'll see me giving all my solutions. So here are my solutions. Okay, there are all my solutions, and take care in the last one that we go 2x times 2x. So one of the things that you hopefully have seen is that there is a pattern here. So in my first example here, I can see that in each bracket, what I've got is the first term is the same each time, and the second term is the same each time. But what changes is in one bracket I've got an addition, and in the other bracket I've got a subtraction. Let's look at the next bracket. I can see it's the same. First term is x and x. Second term is 2 and 2 in each bracket, and then 1 is subtracted and 1 is added. Now, these patterns will only work if we've got those ingredients. That is, the first term matches the first term in each bracket, the second term matches the second term in each bracket, and then I've got one addition and one subtraction. So what is the pattern? What I end up with is the first term squared, that gives me my x squared, and the second term squared, that gives me my 1, and they are subtracted. And you may have seen or heard of this. It's called difference of two squares. And the reason it's called difference is because difference means subtract. Okay? And two squares, well, the first one is the x squared, and the second one is the 1 squared. So I've got two different things that are squared, and I'm finding the difference between them. So this is the name we give to it, and we often just shorten it and call it dots, difference of two squares. So I will quite often call it dots. Sometimes you'll see it called dops. Not in our book, but if you ever look at some different resources, you might see it called DOPS. The P stands for perfect, difference of perfect squares. Because these are all perfect squares, the 4 and the 9 and the 25. Those numbers are all perfect square numbers. So if I look at the second one, I've got the x squared, I've got the 2 squared, and I've got the subtraction in between. In example C, this x is squared, this 3 is squared, and I've got the subtraction in between. In this one, I've got the x squared and the 4 squared and the subtraction in between. Now, don't be fooled by the fact that in example E, my 5 is first and my x term comes second. I still take the square of the first term, which is 5, so this 25 is my 5 squared, minus the x squared. And in this one, when I said take care, that's because we don't just want 2x squared, we want the 2 to be squared as well. So when I square 2x, I get 4x squared. And then I subtract and I get the 9. So let's look at what we've got. What do you think the rule is? Make a prediction. What do you think the rule is for expanding a minus b times a plus b? Write down what you think it is. And this is what the rule is. A squared minus b squared. Ooh, that's a bit wonky. And as I said before, this is called difference of two squares. So you should definitely write this down. difference of two squares, which we call dots. We're going to use this a lot. You're going to see it a lot, so make sure you've got it in your notes and that you remember it and that you practice it. So that's what we're going to do next. Let's do some practice. So this time we're not going to use FOIL. Definitely do not use FOIL to expand these. Use the pattern to expand these brackets. So what you should do now is pause and do them yourself on a piece of paper. Then hit play again and watch me do them so that you can check your answers. Now I'm not going to go fast through these. I'm going to go through them nice and slowly and explain what I'm doing at each step. So here are my solutions. X plus 7 times x minus 7. The x's are the same, the 7's are the same, and I've got one addition and one subtraction, so it definitely fits the pattern. So I square the first term, that's x squared. Oops. Try that again. X squared. And I subtract, and then I square the second term, that's 7 squared. You don't need to write that step. You can go straight to just writing x squared minus 41. Next one I'm going to do the same. A and A, 10 and 10, it's a match. One subtraction, one addition. I've got to check that every time because eventually we'll have mixed problems. So get into the habit of checking it, don't assume. But it does fit the pattern, so I square the first term and I square the second term and I subtract them in between, which gives me A squared minus 100. For this next one, you'll see why I like to do this. I like to write 2y squared. And then minus, I don't need to write the 1 squared, but can't hurt. Now, of course, it's not negative 1 squared here. I'm subtracting the answer to positive 1 squared. So that's going to give me minus 1, and of course this gives me 4y squared. For my next example, again, I've got to be really careful. I'm going to have 3x squared here, and I'm going to subtract 4 squared, which gives me the 3 squared is 9, the x squared is x squared, subtracting the 16. Let's check again for this one. I've got 2x and 2x, they match. I've got 5y and 5y, they match. And I've got one addition in the bracket and one subtraction. So it does fit the dots pattern. So I'm going to square the first term and square the second term, which is 4x squared minus 25y squared. Now, it is possible, if you forget this expansion pattern, to expand using FOIL and you're still going to get the right answer. If we had a maths test, there's no way I'm going to mark you wrong because you had to use FOIL to expand. But it's better that you try to learn this technique because later what we're going to be doing is going back the other way. We're going to start with x squared minus 49 and I'm going to ask you to be able to put it in brackets. So it's really important that you learn this pattern at this stage so that you can use it later on. Okay, I'm going to do the last example. I've got x plus root 2 and x minus root 2. So there's a little bit of server revision for us here. I'm going to square the first term. I'm going to subtract, and then I'm going to square root 2. And of course, if you got it right, you know that the square of root 2 is 2, because that's the definition of square root. If I square it, I'm going to get the number under the square root sign. So in fact, whatever number, square root of that number, and then squared, is going to give me that number underneath. Okay? All right. I don't think there's anything else. Oh yes, there is. I've got a summary for you. Difference of two squares. When the brackets have the pattern of the same terms, with one addition and one subtraction, we can skip FOIL and use the shortcut rule, which we call dots. A plus B times A minus B equals A squared minus B squared. And that's the end of our little lesson on difference of two squares.